In this particular problem, we have a steel framing system. So steel framing systems provide cost-effective solution for low-rise buildings. They have high strength to weight ratios and can be prefabricated and custom designed. Consider the following two-story building construction with the steel I-beams. So we need to determine the deformation and stresses inside the frame due to the application of uniform load of 50 kilonewtons per meter, which is applied on the second floor as shown below. So we are going to try to solve the particular problem and find out the deformation and stresses in the Ansys workbench.
So in order to solve this particular problem, we have opened Ansys Workbench and drag and drop the static structure onto the project schematic. We need not change the material as the members are made up of steels. Then right click on geometry cell and import this geometry. And double click on the model cell, but our Ansys mechanical did not open. To resolve this issue, right click on the geometry and select properties. And the properties tab is open here. So in this particular properties tab, while we are going to import the bodies with the lines, we need to select this particular option as well. So if we don't select this particular option before importing the geometry, what happen? Only the surface bodies or the points that are contained in this geometry file will be imported, but the line bodies will not be imported. Select this checkbox. Now right click on the model cell and click on update. Now double click on this model cell in order to start the Ansys mechanical and zoom it out. Once we open this geometry, it is showing some question mark beside the geometry branch. So expand this branch and there are lot of steel members or line bodies. Select every line body and we find out what is error. See here, the error is we haven't defined any cross section for any of this particular frame members. So what we need to do is we are going to close the Ansys workbench, and remember this because a lot of people, while they are importing these line bodies, they directly import this particular bodies and they don't give the cross section and directly come into Ansys mechanical. So that is why, to show that particular problem, I have done this. Now I am going to double click on the geometry cell to open design modeler. Now what I am going to do is, as for the specification, this particular member are made up of I cross section. So right click, generate, and once I generate this particular structure, we need to apply the cross section. Now we go to this concept, go to cross section, and in the cross section select I section. Now instead of rectangular cross section, we can see the I cross section, and here we have to define this particular properties for I section. So if you don't know what W1 means, W2 means, you can just go to this graphics window to get the reference. So for example, if you say what is W1, W1 is nothing but width of this particular flange, and T3 is thickness of this center section. So we have to give this particular data, and this particular problem is defined in meters, so do not change the units. Now we will give the value of these particular properties. The W1 is nothing but 0.1715, and then W2 is also the same 0.1715. Then coming to this one, it is 0.3556, and then this one is 0.0073, and this one also 0.0073, and finally this one is 0.0115. So I have entered all the dimensions of this I section and expand this particular branch, and now instead of managing 26 parts, select all of these entities by just selecting the first entity, then pressing down shift button and select the last entity, and then assign the I cross section to every member. And now we have finished with the modeling, and then close this particular design modeler. Now right click on the model cell and update it to refresh the data, and then double click on the model cell in order to open the Ansys mechanical. Once it has refreshed the data, it will open the Ansys mechanical with all the cross sections applied to the frame members. So here you can see the question mark is removed from here, and then right click and select mesh, and once I generate the mesh, then apply the boundary condition as well as this forces, and I try to solve this particular problem. And here I will tell you one common problem which is known as the solver pivot error. We will see how to reduce the error. For now, right click on static structural, then click on insert and then apply fix support, and then select these 6 points and press apply. So we have given the fixed support. Now right click on the static structure, insert and insert a line pressure. So select this particular line and apply, and change the define by 2 components, and here give a load was minus 50 kilonewtons per meter. Okay, so once we have given the line pressure, now just right click and copy this line pressure, and we are going to paste it on the static structure. So from the new line pressure boundary condition will be formed. So select this line pressure, select this and change the edge selection to this one instead of this one. So likewise, we will do the same process for 7 times. So once we have selected all the required edges, then select all the images at once, and we have to check whether there is an overlap or not. So right now we don't have any overlap, so just right click and select solve. As I told you, there is a solver pivot error. It is being shown here. There are different reasons for this particular solver pivot error to occur. Generally, people haven't give enough constraint to the model, but in this particular model, we have given all the required boundary conditions or constraints, so it is not the reasons here. The main reason is that we haven't created a context between the line element. Generally, what happen if this particular line models are created inside design modular, then Ansys mechanical will effectively create the context between two or more members between the members, but at this particular model has been imported from other geometric CAD system. So we need to create connections between all of these particular beams. That is why it is showing a solver pivot error. For that, click OK and minimize this and double click on the geometry, and now instead of manually creating connections for every point, we can select all the 26 parts. Right click and select from new part. Now this all 26 members will be acting as a part of a new single body, and the automatic connections will be effectively generated by this Ansys mechanical only. Now close the design modular once again and just right click and select update. So that the data we have changed, it will updated in Ansys mechanical. So switch back to Ansys mechanical, right click and select solve, and see the solver pivot error will not be occurring because of all the joints between these frame members have been created successfully, and we got the solution. And now just right click and click on deformation and select total deformation, then right click and evaluate the results. Here we can see the total deformation in the frame. Again right click on the solution, insert and go to beam results tool and select axial force option. So right click and click on evaluate all the results. So in this particular member, it is being experiencing an axial force of 12255 Newton. Then right click, insert and go to beam results and select bending moment. And now evaluate the result, and this is the amount of movement that is being experienced by this frame. So just right click, insert beam results and select torsional movement. Every member in this particular geometry has been selected, so we do not want change anything. Then right click, evaluate the results, and we get this torsional moment for the total body. OK. So this is how we can use the different beam tools that are represent inside Ansys workbench to solve 1D problem.